Greetings. The homework on 2.5 exact equations, it might sometimes, these functions like sometimes be daunting, rather big functions, but okay, we are in a higher level course and this is the type of functions we're going to run into when we do differential equations. So here, oh, this is a dy obviously, right? This is the number 13. This is part of the exact equation, so we know this is going to be an exact equation. In fact, I don't know, perhaps the question asked to verify whether it is. So let's first address this. So if you have, it's an equation of this form where m and n depends on x and y, but let me not write it here. And then for it to be exact, what we need is that the partial derivative of m with respect to y should be the same as the partial derivative of n with respect to x. Remember, it's the opposite variable that we here have. Okay, and let's verify this. Okay, so the partial derivative with respect to y, of which one? Let's write down x. Now, it's a quotient rule if you want to do, but I don't like quotient rule. So I'm sure you're going to do it with the quotient rule, but I don't like it. So I'm going to write it this way with negative exponent. So what is this? Okay, so with respect to y, okay. So this x here, the first x in front of it is a constant. But then we have a power, and inside is a function. Okay, so take the derivative of that power is, so no, the x is a constant, we copy that. Then we get the power rule says that this will be the result. But I have to plug in the inside function, which is x squared plus y squared to the power minus, sorry, not the power, of course, that's part of the inside function. So this brackets were not necessary, right? X squared plus y squared. And then I have to take the derivative of inside function, but remember, it's only with respect to y. So we get a 2y here. Okay? Now, let's do what is the partial derivative with respect to x of this other guy. That was y over, again, I don't like the quotient rule, so I'm going to do it this way. X squared plus y squared minus 3/2. And I have to do this with respect to x. So now this y in front here is actually a constant. So now I have to deal with that power, minus 3/2. So the exponent comes down at 1 to the, sorry. Sorry. We are taking derivative, so we're subtracting from the exponent. So I was going the wrong way here, right? Now, if I do twice the same mistake, then it would have cancelled out. But I shouldn't do that, obviously. So we're taking derivatives here. So the derivative is, of course, the powers go down. So we get minus 5/2 here on both sides. And inside comes the inside function, which is x squared plus y squared. And now I have to take derivatives of that inside function, but again, with respect to x. So the only part that we have is 2x. And so now you see that these two are actually equal, right? The x and the y just a swapped position. So this is exact. So it is exact. Okay. What does that mean? It means that there is an f. So our solution will be of the form f equals c, where f is going to be a function of x and y, and c is a constant, such that this, let me do it in a different color here, that this guy is going to be f of x, and this guy is going to be f of y. Okay? So in other words, the m was actually f of x, and the n was actually f of y. And what was this then? This was saying what? So if m is f of x, and now you take the y of that, then we have f, the partial of x, and then with respect to y. What is this? N is f of x, n is n of y, sorry, f of y, and then we take the partial with respect to x, which is the same thing as the previous thing, except the order. And the whole point is that the order doesn't matter. In partial derivatives, whether you do first derivative with respect to x and then with respect to y, it doesn't matter, because one time you're taking the other variable as constant, and so it never interferes in which order to do that. Okay, but that's not what we want to do. What we need to do now, so that was everyone step 1, verifying. Step 2 is to solve it. Now we can use either one, the red or the blue, to antiderive, to do the antiderivative, the partial antiderivative. Let's do there's no reason to do not the first one. So what I'm going to do is I'm going to say, okay, if I antiderive the first one, let's do it in black, then I get f, because that's what I should be getting, right? So we have to do this, right? X squared plus y squared to the power 3/2 dx. And this is antiderivative with respect to x. That means, in this case, y is a constant for us. What kind of integration should I do here? I think there's only one thing that actually really works, that is a substitution. We have an inside function, we have a denominator, but even in there it's a power, so even in there, so it's sometimes you take the whole denominator, but this time it's better not to. We take w is x squared plus y squared, because then dw is 2x dx. And remember, y is a constant for us at the moment. Okay, so the notation doesn't encapsulate that, so we have to keep that just in mind. Okay, and so we dw over 2, that is x dx, and now we can replace everything. So let's see what we get. The x dx becomes dw over 2, and then this power, and since I'm going to have to antiderive, I'm going to write it with negative exponent. That's that. And so antideriving, now I have to add 1 to the exponent. Okay, so now I'm correct. Divide by that exponent. And we have also a 1 over 2 here, right? The 2 is going to cancel. And then we have a constant here that is constant with respect to x, but might still depend on y. Now there's this w there, but don't forget that w is actually this, so we should have plugged that back in. So the minus a half and a half cancel. Well, the two halves cancel, right? This is a half in the denominator, this is a half in the numerator if you want. If you don't see that, flip it over, whatever, they cancel. So what we left with is minus 1 over w, but this w is x squared plus y squared to the power a half. I'm putting the negative exponent to make that into the plus phi of y. And so the next step is to determine phi. So what is phi? And that we do from looking at the blue guy. So now we say, we know that f of y should be equal to this quantity here, y over x squared plus y squared to the power 3/2. Okay, this is the given. How do I find f of y? Before, that's what we started finding, right? So be careful. Now, don't say, I have to interderive this, so that's how I f of y. No. You did already antiderive with x, so you did already find f. Not fully, because there was a part of f that you didn't know yet. This part, the part that depends on y, that's not completely clear. But the part that depends on x, this part is known. And it's from this one that we now plug in. So perhaps to clarify this, let me put this in colors here. So this is f. Okay, so this is f here. And this is the f I'm going to use to calculate here f of y, the partial derivative with respect to y. So I do the partial derivative with respect to y of this thing. Let's see. Perhaps in this case I'm going to write it. I should have not perhaps written it with the exponent already in the denominator. So let me write it again like this here, because I'm going to have to do the power rule. So the power rule says, okay, minus 1 is there. Then you bring down the exponent and then subtract 1 from the exponent. So subtracting, remember, we're taking derivatives. Professor, don't make that mistake anymore. Okay, so minus 3/2. We're taking derivative with respect to y. That was an inside function, right? So we still have to take derivative of that inside function. That is 2y. Right? That's what we do. Plus, now don't forget there's this little tail here, f prime. That's the only thing we can say about it, is f prime. And that has to be equal to this expression here that we had already written down. Okay. Now, some things have to be canceling, otherwise there's a problem, right? Let's see. The minuses cancel. This 2 cancels with this 2, and we have x squared y squared minus 3/2 y. That's exactly this guy. Okay. So remember, these are equal, right? So this is equal to that, and now we see that the whole thing cancels with the whole thing. So what are we left with? Well, 0 is phi prime, and that means that we can take phi equal to 0. Only one solution we need. So that's why I can take whatever I want. Of course, the general solution would be a constant. So, conclusion, step 4. The solution to this problem is this f. Now we put this f equal to c. F equals to c, so this in this case that would be minus 1 square root of x squared plus y squared equals c, where c is a constant. Now, this step, we found the solution, but the way it is written always, when you do this, it's basically in implicit form. And so sometimes you want to find the explicit form. In other words, solve for y. So solve for y if possible. Well, let me put it this way. You only have to do this if it's asked that you should do this. Let me see. Let me look at the actual problem here. Sorry, I have to give me 1 sec here. I'll pull up the problem number 13. No, it didn't actually explicitly ask it, but let me show you how you would do that. So, because I'm sure in the back of the book they might have also have done this. For one thing, this is a kind of a weird way of writing this thing. Let's bring the radical out. So here we would have c times x squared plus y squared equals -1, and so perhaps we would bring the c to this side. Okay. Oh, okay. So sorry. No, where's my negative column? I had a negative, right? Yes. So, okay. This sounds weird, right? Because now a radical is equal to a negative number. Why do you say that it's a negative number, -1 over c? Why is that negative? It's negative if c is positive, but what if c is negative? It's positive. So from this, because we use exponents, we kind of have determined what radical we take, the positive radical. This sometimes gives a restriction on what these constants can be, what the solutions can be. Of course, I mean, if you're looking for complex solutions, then it could be anything. But let's focus on real solutions here. So you could say, okay, this actually should be a constant k, and it should be a positive constant, otherwise in problem. But then you realize I can take the square of both sides, x squared plus y squared equals k squared. That is also an implicit equation still, and this is actually one that you recognize right away. This is the equation of a circle. It's centered at the origin and radius k. So remember, these are the solution curves, and if you would plot we have a first order equation, and we can look at the direction field. And so if you would make the direction field and you would take any solution you see, it's all circles. Okay. Now you can still solve this further for y, because say y squared is k squared minus x squared, and there y is plus or minus, because there are two possibilities depending which part of the curve you look at, square root of that. So this is the really explicit form, but the disadvantage of the explicit form is that there are two branches, if you want, the upper part of the circle and the lower part of the circle, whereas this is implicit, but it is much more telling. Now, this is also correct, of course, but it's even gives less information what geometrically, what is the direction field, what are direction fields actually showing you. Okay? Now, these are little tiny comments that I make. As I said, if this is what they ask you, then that's fine, you're done. Okay. So let's go to the next problem. That was number 20, if I'm not mistaken. And number 20, we have y cubed minus 1 ex dx plus 3y squared ex plus 1 dx, dy, sorry, equals 0, and there's an initial condition, namely it has to go to the origin. Okay. Again, let's verify that is indeed exact. So we have to take the partial with respect to y, because this is the part that sits next to dx. If I do that, then ex is just a constant for me, so the only thing that I have to take derivative of is this y cubed minus 1, that is 3y squared, and I just copy the ex. If I take the partial with respect to x here, the other variable, then now I have to do the inside part. The 3y squared is just a constant, but the inside ex plus 1, well, that is just ex, right, the derivative. And you see that these are equal. So yes, it's an exact equation again. All right, so step 2, remind you that this quantity will be f of x, f the partial with respect to x, and this will be the partial with respect to y, and then whatever f is, that gives me the general solution. Okay, so step 2, you see here that there are two types of integrals that you're going to have to deal with. On the left hand side, if you would interderive with respect to x, because remember, why interderive with respect to x? So didn't you just say it had to be y? No, that's the derivative to verify the exactness. When it comes to finding the f, well, we know that this is the partial with respect to x, and we want to undo this operation. And undoing the derivative is an antiderivative integration. So now this is perhaps even easier to interderive with respect to x, so let's just do that. Okay, I'm just going to do that. So I'm going to say f is the partial antiderivative of this guy. Okay, if you want, so if you want to memorize it somehow, it is really just this whole thing, and you put an integral sign in front of it, right? That's really what it is. Okay. And that in particular tells us that this y cubed minus 1 should not bother me, and then the antiderivative of ex is just ex. So I explain, perhaps this is just constant, so it can move out. This is not a constant. It's not that I moved that out, it's just that the antiderivative of ex is ex. That's the way things are. Now, be careful. This also always, we want only one f. You say, since we want only one f, Professor, why can I not just write 0 here then? You did that in the previous case. No. At this point, the constant itself, the actual constant in the final solution, yes, that I can take 0. But this is a constant with respect to x. That's much weaker, right? This is not a real true constant because it still depends on y. So I have to write it. Okay, going on, moving forward. I know now that this expression here, if I take f of y, that I get the blue guy, which is 3y squared ex plus 1. Okay. So let's see what we get. If I take derivative of this one, so this is now what I'm calculating this one now, based on this expression for f. What I'm doing, respect with y. So this is the y part that I have to interderive here, 3y squared ex, and then plus phi prime. Okay. Now, be careful. You say, oh, it cancels. No, be careful. It doesn't really cancel, because we have to actually, there's a sum here. Let's expand this. 3y squared ex plus 3y squared. So you see that something cancels. And we know what has to cancel is everything that has an x in it has to cancel. Might be some of the y's cancel too, but we cannot have anything x left. Otherwise, it's wrong. So conclusion, we find that f prime is 3y squared. Well, but then it's easy what f phi is, right? Phi is 3y squared dy. I said f, but I meant phi here. So that is y cubed plus a constant. Yeah, but I only want solution. Now this is a true constant, and that I can take 0. So conclusion, f is now, we know what f is, so y cubed minus 1 ex plus y cubed equals a constant, because don't forget equals a constant is actually what gives you the implicit equation. We need an equation at the end, right? Just an expression. If I would just look at this thing, what is that? Well, that's just an expression in x and y. That's not a function. That's not a curve. That's nothing. An equation gives curves. Okay. And let's try to make it explicit again. So don't we do, if it's not now asked, then we should not really have to bother with that, but I'm going to do that. So step 4, we also have to do the initial condition first, but let's first make it, well, yes, the initial condition you can do at this point already. So perhaps just to show you that you can do this at this point, let me do that now. Although you would normally first find the explicit equation to do it, but it can be done here. Now the initial equation was that y0 is x0. So if x is 0, then y is 0. So this means just plug that in and calculate what c is. Okay, I plug that in. I get minus 1 times e to the 0 plus 0 equals c. So that means that C is negative 1. Right? That's the conclusion, right? Okay. So what we have now? So we know that C is minus 1, but I'm going to have to solve for y, so I'm going to take the terms. Let's expand this first. This is that minus EX plus y cubed is negative 1. We know that is negative 1 now. Now we group the terms with that have an y and factor out a plus 1 here. And let's bring this minus EX already to the other side. That becomes a plus EX minus 1. I want to isolate y, so y cubed is EX minus 1 over EX plus 1. And finally, y would be then the cube root of this thing. And there's no need to consider here negative positive because cube roots respect the sign. Okay, and so this is the really true solution in form of the graph of a function, in explicit form. Okay, so I'm gonna we have a review on this because there will be a quiz on exact equations, and I will do a few more problems there then. This is perhaps the first, you see, we have now already a couple of different type of differential equations, and they all have their method, and this method is perhaps the newest in the sense that we're using these partial derivatives. That's something that we had not done before, that you had not seen before from calculus, what I mean to say. Okay.